Okay, good afternoon. Today is day 3 of probability. Yesterday we learned about uniform and non-uniform probability. Where uniform is you have the equally likely or unlikely for an event to happen. And then non-uniform will be where it's not equal. It's unequal for two events to happen. So today we're gonna be able to calculate a theoretical probability, okay? And then the first problem, and think about it says, without flipping the coin, do you think is the probability of a coin landing on heads? Right? So in terms of that, I wrote up the probability equation. So probability of heads, so number of heads on a coin. Number of heads on a coin is only one. Out of how many sides a coin has? It has two sides. So the probability of rolling a heads would be 0.5. Or you can say it's 50%. There's a 50% chance of you getting a head, right? Excuse me. And then it gave us a table, and then in the table it's asking us to do the trials. So I went ahead and I found this coin. This is my heads on the coin. And then you have the tails, okay? So I'm gonna go ahead and do the flips so we can see using the trial, right? So for the trial, let's do the first one, okay? The first one, it was a tails. So I'm gonna put T for tails. Let's do it again. Okay, the next one I rolled was a head. Do it again. Head. Let's do it again. It's not flipping. Hold on. I'm going to go ahead and do the rest of the trials. If you guys want, you guys can do the trials too. And then we're going to come back and talk about the observed relative frequency that we observed in this trial. Okay? Okay, so I went ahead and I completed 10 trials. The first try I did, it was a tails, then head, 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 then tail, 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 and then head, head. Okay, those were my trials, and just a disclaimer, I did not cheat. I just did like this and I rolled it, and then that was the outcome that I got. Okay, so the next one, it says after you did the trials, I did it. It says determine the observed relative frequency of flipping a coin and it landing on heads. Show your work. So the relative frequency, it's talking about the number of heads that are presented in the table divided by the number of trials that are there. Okay, so let's count how many heads we have in the table. 1, 2, 3, 4, 5. So I have 5 heads in the table, and then the total number of trials is 10. 5 out of 10, that's 1/2, and that is equal to 0.5 or 50%. That's funny that it came out to 50% too. By just flipping the coin 10 times, I was able to get the same amount by just looking at the possible outcomes that are there. Okay? So theoretical probability is a ratio of the desired outcome, in this case heads, to the total number of outcomes. So the desired outcome that we had in this theoretical probability was heads, and then the total number of outcomes that was presented in this problem was 2, because you had 2 sides to the coin. It's either heads or tails. So 2, and it was 50%. I did the trial, and my observed relative frequency was also the same, so it matched. Also, it went on to say observed relative frequency is a probability calculated from an experiment. So I did my experiment, and for some reason it came out to be the same thing as the theoretical probability. Okay? So the key point for this lesson is theoretical probability describes what should happen in a chance event. Remember, I did not control where the coin lands or which one or which part of this coin it's gonna land on. There's no control. Once it leaves my hand, there's no control. So I can't say it's going to be heads or tails because I don't know. It's by chance, okay? So the theoretical probability describes what should happen in a chance event. And that's what we just did. And this is what the key point that we're going to apply to the next two problems. All right, so I wrote the key points on this page, as well as I went ahead and I did the interaction with new material scenarios. And the key point says, theoretical probability describes what should happen in a chance event. For the interaction with new material problem, it says, Barry, Michelle, and Sasha are conducting different chance experiments as outlined below. These are the experiments. Order the names from the person whose probability will be most likely to the person whose probability will be least likely. So we're going to go ahead and use what we said. Remember, theoretical probability is the probability of that thing happening divided by the number of outcomes, right? So in terms of Barry's, it says roll a 6-sided dice and try to land on a number greater than 3, okay? So what you can do, you can write out the 6-sided dice to see what we have. So some of the outcomes would be 6 sides. So we have 1, 2, 3, 4, 5, 6, right? And then you're thinking about the numbers that are greater than 3. 4 is greater than 3, 5 is greater than 3, 6 is greater than 3, okay? So in total, for the probability for numbers that are greater than 3, that is equal to, we have 1, 2, 3. So we have 3 possible outcomes that are greater than 3. Divided by, we have the total outcomes, which is 1, 2, 3, 4, 5, 6. Divided by 6. That's going to give us 1/2. And that probability is 0.5 or 50% chance of you rolling a number that is greater than 3. Okay? This is the theoretical probability in this chance event. Okay? Let's move on. So Michelle picks a random marble out of a bag that has 15 red marbles, 20 blue marbles, and 15 yellow marbles. So 15, 20, 15, and tries to pick out a blue marble. Okay? So let's go. First we have the sampling space. We have red, we have blue, and we have yellow. Okay? So the probability of us actually picking out a blue, we need the number of blue marbles that we have. So we have 20 blue marbles divided by the total number of marbles that we have. Okay? So right here we have 15 red plus 20 blue plus 15 yellow. That's going to be 20 divided by 50. You can cancel that out. This is going to be 2/5, or that's going to be 0.4 or 40%. Okay, if you want to put it in terms of percentage. Okay, 40%. So for Barry's, it's 50% chance that his outcome is going to come to pass. For Michelle, it's going to be 40% chance that her event will happen. Let's look at Sasha's. So Sasha's, she has to spin the spinner and try to land on a composite number. So in this sample space, we have 1, 15, 13, 11, 9, 7, 5, 3, and 1. Okay? So in this sample space, you need numbers that are composite, meaning that they have factors. Okay? They're not prime numbers. They have other numbers other than themselves and 1 that can divide them. So the first number, 15, is a composite number. So prime prime, prime. 9 is a composite number. 7 is prime. 5 is prime. 3 is prime. And 1. Let's erase this one because I wrote it already. Sorry about that. Okay? So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So the probability of her doing a composite, so composite number, is equal to the number of composite events that we have. So 15 and 9, we have 2 numbers that are composite, divided by 1, 2, 3, 4, 5, 6, 7, 8 numbers in total. This is going to give us 1 over 4. Or as a decimal is going to be 0.25. Or as a percent is going to be 25%. Okay? So these are the different events that we have. And then the problem says, order the names from the person whose probability will be most likely to the person whose probability will be least likely. So most likely would be the highest percentage, which is Barry. So I'll just put Barry's name first because we're writing them in order. Then Michelle is 40% chance that her event will happen. So Michelle is next. And finally, we have Sasha, because Sasha has a 25% chance that her event will happen. Okay? So the answer to the problem is right here. We listed the sample space and we were able to use a theoretical probability to describe what would happen in a chance event. So 3 different chance events, and we were able to solve those problems. Now that you have seen this model, I will be posting these guided notes online. You guys now have the opportunity to go in and use what you just learned to complete the independent practice problems. Enjoy the rest of your day and be good.